Hello. Today we're going to do the third part of transformations. We're going to review translations and reflections to begin, and then we're going to finish up with the new transformation of dilations and how to write them, identify them, and apply them. Okay? So just real quick, there are three transformations. So you can see them here, translations, reflections, and dilations. We'll review the first two, and then we'll learn the new type. Okay? So let's take a look at this first function here. If you were to add 6 to the inside of your function, anytime you add or subtract inside the function, that is always going to be a horizontal translation. Now, when it's inside the parentheses, we need to make sure we use the inverse. So it is going to be to the left 6 units. Okay, you would think addition would move it to the right, but instead, when you see addition inside those parentheses, we know we need to use the inverse of addition, which is subtraction, and that would actually move your graph to the left. All right, let's take a look at this next one. If I add 9 to the inside, that's still a horizontal translation. But this time, because it's minus 9, I'm going to go to the right 9 units. Okay, so let's move on to the next translation. If you add 8, now if you notice that this time the 8 is not inside the parentheses, it's just being added to the end of my function. So when you add that 8 to the end, that is now a vertical translation up 8. Okay. Well, now I have both, right? So we have two answers to this question. We are going to have a horizontal translation. And because it's minus 5 in the inside, we're going to go to the right 5 units. And then the 7, because it's added on to the end of my function, it's going to go up 7 units. Okay, so right 5 and up 7. All right. So again, this time I put it all in there. I don't know if you guys remember from the last lesson, but we have 3 answers to this question. So anytime that you see this negative up front, we're going to get a reflection over the x-axis. Then I have a horizontal translation, left 1, and last but not least, I'm going to have a vertical translation down 4. Okay, so this particular function had 3 transformations in it. All right, so let's try to do it again. So let's see what we've learned. So same idea. If there's a negative out front your x squared, that is going to be a reflection over the x-axis. Okay, always. We got to make sure we write it all too. You can't just write reflection. There's different types of reflections that we'll learn later on. Okay, so it's got to be a reflection over the x-axis. Then I have this plus 10 at the end. So there is a vertical translation up 10. Okay, so there's only 2 answers to that question. Let's see if we got another one here. Oh, let's apply it to a table. Okay, so if I go from one to the other, you can see that I'm going to subtract 4, so that's going to be a horizontal translation right 4. We also have a vertical translation up 1. Okay, now if I go to the right 4, that means I want to take all my x values and I want to add 4 to them. If I want to go up 1, then I would take all my y values and shift all those up 1. Okay, so the x values control where my graph is side to side. The y values control where my graph is up and down. So I'm going to take all these x values and I'm going to add 4. Myself some more room. Here we go. So add 4 to all those x values. And I also want to add 1 because I want to move my graph up. I want to add 1 to all the y values. So if I do that, now I'm going to kind of simplify each one of these expressions into my new table. So negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. Now on the right side of my table, I'm going to add 1 to all those values. So 4 plus 1 is 5. 1 plus 1 is 2. 0 plus 1 is 1. 1 plus 1 is 2. And 4 plus 1 is 5. So now I can plot those points, 2, 5, 3, 2, 4, 1, 5, 2, and 6, 5. Okay. And I get my new function. Okay. Just do it again. All right. But this time I want you to see it looks like I'm missing information, but I'm not. I gave it to you in the kind of a verbal description up top here. Okay. I want to see if we can write the function and then let's complete the table of values. So if I want to take this function and I want to go to the right 5. Okay. So if I want to go to the right 5, I'm going to have an x minus 5 squared. And I want to do a reflection over the x-axis, which means I need a negative out front. So this is my new function, okay? Now, if I want to take, anytime you have a horizontal translation, right 5, I want to take all my x values and I want to add 5. To do a reflection over the x-axis, I take all the y values and I want to reflect them, so I'm going to multiply. We don't add or subtract there. We're going to multiply by a negative 1. So anytime you have a reflection over the x-axis, you will always multiply by a negative. Okay? So if I do this, so all the x values, I'm going to add 5. And then all the y values, I'm going to multiply by a negative 1. So negative 2 plus 5 is 3. Negative 1 plus 5 is 4. 0 plus 5 is 5. 1 plus 5 is 6. And 2 plus 5 is 7. 4 times a negative 1 is a negative 4. 1 times a negative 1 is a negative 1. I'm going to have a 0. I'm going to have a negative 1. And I'm going to have a negative 4. Again, I just multiplied all the y values by a negative 1 because of the reflection. So now, if I graph this at 3, negative 4, at 4, negative 1, 5, 0, 6, negative 1, and 7, negative 4, we get a graph that's upside down because of the reflection, which is good, and it's shifted to the right 5 units, right? So this graph that we just made is for this function, okay, negative quantity x plus 5 squared, all right? Let's do that again, all right? So again, I gave you a verbal description. So I have this reflection over the x-axis, which means I want to take the y values and I want to multiply them by a negative 1. Then I want to take the horizontal translation. I want to go left 3. So I'm going to take all the x values and I'm going to subtract 3. And then I want to go up 2, so then I'm going to take all my new y values and add 2. So let's do this step by step here. So let's start. The reflection over the x-axis, we want to multiply by a -1. Okay, so that's where we start. Then we have a horizontal translation left 3, so that's going to go to the x values. We want to subtract 3. And then last but not least, we want to go up 2, so we want to add 2 to all of these new y values. All right, so let's do this step by step. Let's start with the x's, and then we'll go to the y's. -2 minus 3 is a -5. -1 minus 3 is a -4. 0 minus 3 is a -3. 1 minus 3 is a -2. And 2 minus 3 is a -1. Okay, so let's go to the y values. Now we have to follow order of operations here. You have to do multiplication first, then your addition and subtraction. So 4 times -1 is a -4, plus 2 is a -2. And you can use your calculator to assist if need. 1 times a -1 is -1, plus 2 is 1. Okay. 0 times a -1 is 0, plus 2 is 2. 1 times a -1 is -1, plus 2 is still 1. And 4 times a -1 is a -4, plus 2 is a -2. So now if I plot these points, -5, -2, -4, 1, -3, 2, -2, 1, and -1, -2. And I get my new function. Now, if I wanted to, I can also write the equation of this function. Because of the reflection, I know it's negative. I'm going to go left 3, so x plus 3 squared, and then up 2. So this would be the equation for this graph. If you were to put that into your calculator, I bet you get the same graph. Okay? All right, so let's talk about the new type of transformation that we have here. It's called a dilation. Okay, dilations are when we have multipliers that are not negatives, right? So if I multiply it by 2, if I multiply it by 10, if I multiply it by a fraction or decimal, right? Those have effects on our problems. So this, when you multiply on the outside, this is a vertical dilation factor. And when I multiply it by a value on the inside, that's going to be a horizontal dilation factor. Okay, so we're going to look at both one at a time. Now, one thing to note when we get to these, and I'll bring this up again, but when we do horizontal dilation factors, we always need to use the reciprocal. And I don't know if you remember the word reciprocal, but that's when I take a fraction and I flip it upside down. So I'm always going to use the reciprocal of the number inside. You cannot do a horizontal dilation without doing the reciprocal. Okay. All right, so I want you to take a look at these graphs. All right, and I'm going to talk about them very briefly. So if you look at the very first graph, y equals x squared, that's just your basic quadratic. But the second graph, when I multiply it by 5, what it does is it takes my graph and it stretches it vertically by a factor of 5. So this is a vertical stretch. Okay, that's kind of the quick way to write it, but for your QPC, we got to write very specific. But this has a vertical stretch. Now, when I multiply it by a fraction or a value less than 1, right, a decimal, okay, I'm going to get what we call a vertical compression. All right, so if I multiply that x squared by a value bigger than 1, it's a stretch. It's going to stretch my graph vertically. And then if I were to multiply it by a value less than 1, it's going to compress. It's going to shrink my graph vertically. Okay, very important. So you take a look at this graph. If I were to go from x squared to 5x squared, This has a vertical dilation factor of 5. Now you have to write one more thing for me. Because 5 is bigger than 1, not only do you have to tell me it's a vertical dilation factor, but you also have to tell me that it's going to stretch your graph vertically in the up and down direction. Okay. Now, if you have a 1/5, this is still a vertical dilation factor. But it's of 1/5. Now, because 1/5 is, if you use your calculator here, it's something like 0.2. Because that number is smaller than 1, then that is what we call a compression or a shrink of my graph, right? I'm compressing it. I'm making it smaller, okay? So, just kind of quick review. When it's bigger than 1, you're going to have a stretch, okay? When it's smaller than 1, it's going to be a compression. Okay, so that's the idea. And then always remember previous lesson, if it's negative, it also has a reflection. We'll do some of those too. Okay, so let's take a look. Let's put some pieces together here. So if you take a look, I'm multiplying the outside of my function by 5. So I have a vertical dilation factor of 5, which is a stretch. I also, because I have x minus 3, I'm going to have a horizontal translation right 3 units. Okay, let's do one more. So here I have a multiplier of 0.25. So that's going to be a vertical dilation factor of 0.25. And because that number is smaller than 1, it's going to be a compression. And then I have a vertical translation down 9. Okay, because the minus 9 is not in the parentheses. It's on the outside. Okay, so putting the pieces together here. All right, so now there's another type of dilation, right? So if I do the multiplier on the inside of the parentheses, so, if I scroll back up real quick, you can see on these graphs how the 5 is, there's no parentheses there. The 5 is on the outside of my squared. The only thing being squared in this function is the x. But when I put that multiplier inside my parentheses with the x, now we're going to get a horizontal dilation. And what happens here, the big note, okay, whenever we have a multiplier, okay, is we always need to do the reciprocal. So if you have 1/3, then we are going to use a 3/1, which 3/1 is just 3. Okay. If you had a 3, well, we can write 3 as a fraction, 3/1. We're going to flip it to 1/3, okay, which is 1/3. Or if you look at a decimal, 0.3 repeating. So we have an added step. When we do these horizontal dilations, we have to look at the reciprocal of that value. Okay, that's the big idea. We always need to do the reciprocal of that value. And then once we do the reciprocal, same rules apply. Okay, so if you take a look at this, okay, we have a 1/3 on the inside. So what I do very first is I'm going to take that 1/3 and I'm going to flip it upside down. Reciprocal. 3/1 is just 3. So I have a horizontal dilation factor of 3. And because 3 is bigger than 1, it's a stretch. And you can see that in the graph. The graph is stretched horizontally, okay? The graph is stretched in a horizontal direction, okay? Now, likewise, if you look at this 3x squared, well, if I take 3, I can write 3 as a fraction. Now, you can write any number as a fraction by putting it over 1, okay? So if I take the reciprocal, I now have 1/3. And if you want to use your calculator, that's just 0.3 repeating. So this graph has a horizontal dilation. Factor of 0.3 repeating, which, because that's smaller than 1, is a compression. All right. So, 1, we need to do the reciprocal first. Okay. So do the reciprocal first. Once you do the reciprocal, okay, in this case, 1/3 is going to turn into 3/1, which is just 3. Since that's bigger than 1, that's a stretch. Anything bigger than 1 is a stretch. So 3/1 turns into 1/3, or 0.3. That's smaller than 1. That is a compression. All right, so just kind of a review. So always do the reciprocal first when dealing with a multiplier on the inside. All right, so let's put some pieces together here. All right, so if you see this 4, it's a multiplier on the inside. So I'm going to have a horizontal dilation, but not a 4. Remember, 4 is 4/1. We need to do the reciprocal of that 4. Which is a compression, 1/4. 1/4 is 0.25, okay? We also have a vertical translation up 1, okay? Let's keep going. So if you look on the outside here, I have a negative, so that's going to be a reflection over the x-axis. Then I have a 2/5, which it's a multiplier on the inside, so we need to flip it. So the flip of 2/5 is 5/2. So I have a horizontal dilation of 5/2, which if you use your calculator, that's 2.5. Now 2.5 is bigger than 1. So that is a stretch. And then we have a vertical translation up 1. Okay, that's the +1 at the end. So there were 3 answers to this question. All right. All right. So feel free to pause, try to do this one on your own. Okay. I'm going to go through the answer. So if I have a 2 multiplier, now 2/1, right? We can flip it upside down. So I'm going to have a horizontal dilation factor of 1/2, which, because that's smaller than 1, is a compression. I also have a vertical translation down 9 units. Okay, so 2 answers. All right, so this one has a little bit of everything. This has 4 answers to it, okay? Again, feel free to pause. Okay, this problem has 4 answers. So I'm going to try to color code this. So I'm going to start with the negative. Okay, so that negative is a reflection over the x-axis. Okay, so that's number 1. Number 2, the 4 is a multiplier on the outside. We do not do the reciprocal, but I have a vertical dilation factor of 4, and because 4 is bigger than 1, that's a stretch. Next, I have this plus 3 on the inside, which is going to be a horizontal translation left 3. And then last but not least, I have this plus 7, which is a vertical translation down 7. Right? So there were 4 answers to this problem. Okay? All right. There's 4 answers to this problem as well. All right, let's see if we can get them all. Again, feel free to pause. Okay? You can mute. You can do whatever you need. That negative is a reflection over the x-axis. Then I have a multiplier on the outside, because it's the outside here. Okay, that is going to be a vertical dilation. We do not use the reciprocal for any vertical dilations. Okay, of 1/2. And because that's smaller than 1, that's got to be a compression. So now I have this plus 5 inside, which is going to be a horizontal translation left 5. And then last but not least, I have a vertical translation up 6. Okay, so 4 answers to that question. Let's try this one. This one has 2 answers. All right. Again, feel free to pause. I have a multiplier on the inside. So that's a horizontal dilation, but we do not use the 1/6. We need to flip that upside down, which is 6 over 1, which is just 6. And because that's bigger than 1, we know that's going to be a stretch. And then the only other value we have here is this plus 8. That's going to be a vertical translation up 8. Okay. All right. Can we write an equation given a set of characteristics? So let's see if we can't write this equation. So a horizontal translation left 3. So I'm going to kind of set this up. If I want to go left 3, I'm going to need an x plus 3 squared. If I want to go up 4, I'm going to need a plus 4 at the end. And then if I want to reflect it over the x-axis, remember that is a negative out front. And ladies and gentlemen, this is my quadratic function. Okay. All right, let's see if we can do this one. So same idea. Let's say I want to go right 1. So I'm going to say x minus 1 squared. So that's right 1. and then a vertical dilation factor of 5. So that's got to be a 5 multiplier in front. And this would be my function. Remember, dilations are always multipliers. Translations are always being added and subtracted. Okay, so if I ever give you a translation, left, right, up, down, we know we need to add or subtract in my function somewhere. But if I give you a dilation, that means we're going to have to do a multiplier somewhere in our function. Okay, so just kind of a little review here. Remember, we have our translations are what's being added and subtracted, and then we have our dilations when I have a multiplier inside and outside. Okay, anything inside is horizontal, anything on the outside is vertical. Okay, and that pretty much sums up all of our transformations, and we're going to be getting ready to take our QPC soon. Hopefully this helps.